And welcome in, everybody. Welcome into our first of two classes here on area and perimeter. Today's class, we're going to go ahead and be able to identify this as the basics, where we're really going to be focusing on not just, again, memorizing formulas, but knowing how to use them. And I'm going to challenge you plenty of different ways to get there. So first thing we're going to do is we're going to understand the formula specifically for area and perimeter of squares and rectangles. I'm going to limit it to these two shapes and these two formulas because it's going to really help you understand the formulas forward and backwards and inside of word problems. With only 2 hours, I think this is a good, appropriate amount of work that we're going to go over. That way we can build that confidence the right way. Then number two, again, once we really get to know these shapes and these formulas, then we're going to learn how to work backwards. So it's not just going to be about finding the area or finding the perimeter. No, what's going to happen if I give you the area or perimeter and I want you to work backwards to find the sides? Are you still going to be as confident in what you have to do? So that's the big question we're going to answer. And then number three, instead of just working forward and working backwards, I'm going to let you figure out if we have to work forward or backwards in our word problems. And that's going to involve spotting keywords and translating those keywords into the actual math. So there's that 1, 2, 3 today, everybody. So let's go ahead and move forward here, getting started with our formulas, beginning with the square. So let me go ahead and draw this square here at the top left. Perfect. Didn't need any technology for that. Those lines are perfect. So with that, take a moment. Take these notes down for the area and perimeter of a square, and then I will interpret that for you here, and we'll move forward to rectangles. So take a moment, and we'll move forward shortly, everybody. All right, so let's go ahead and go through a quick explanation of these formulas, and a really brief overview in terms of why these formulas actually make sense, and then we'll move forward right along from there. So first things first, everybody, let's go ahead and take a look at area versus perimeter, just a quick difference. So everybody, when it comes to area, what we're talking about is going to be how much space the shape takes. So everything that you see in blue over here inside of the square, that's going to be area. Let me just write area right here. When we talk about the distance around the shape, typically conflated with border, right? Or fencing. Perimeter is really everything. So the distance around the border, the distance around the shape itself. Area is space. How much space are we taking up? So one thing that I'll hint at now that I am going to repeat later on, so don't rush to write this down at all, you're good. But one thing that we have to learn how to do is learn how to identify area without it being actually stated explicitly. Same thing with perimeter. How do we know that we're going to be given perimeter? And I'll go ahead and give you a quick hint now. When it comes to area, let's say we're working with let's say 3 feet and then 5 feet. Well, this is a square, so that's just going to be 3 feet by 3 feet. When we go ahead and perform the area, what's going to happen, everybody, is we're going to do the 3 times 3. And just to help me out, because we all know that I'm bad at math, everybody, 3 times 3, that's going to give us perfect, that's going to be 9. Now, most people know that, right? No, most people know, hey, just take that formula, plug those numbers in, and we're good. But this is where your score is going to be increased by knowing this additional detail. It's always been there, but we probably never paid attention to it that much. Let me zoom on in. Everybody, what were the units that I used for the side lengths? What was that unit there that I used? Yeah, I ended up using feet. So everybody, technically, this is going to be 3 feet times 3 feet. Now, let me just make a little more room to really illustrate this point. Everybody, quick question. If we're doing 3 feet times 3 feet, well, 3 times 3 is the same thing as saying 3 squared, but we can just write that as 9. So that's totally fine. My actual question is coming right over here. Everybody, if we have feet times feet, how do we write that? If we're multiplying the same thing by itself, we said 3 times 3 is 3 squared, so we can write that as 9, whatever. But feet times feet, that's going to be written as, ooh, I love the chat box there. Yeah, that's going to be written as square feet or feet squared, whichever way you want to say it, it's absolutely fine. But let me write this down here in red. Feet squared. You can also write this as square feet. So let me just use black over here, or square feet. Either way is fine. But let me just go ahead and emphasize why this is important. Again, everybody, we're going to be doing word problems where I am not going to tell you that I'm giving you the area or giving you the perimeter or even looking for the area or perimeter. We're going to give you context clues. I think we all know what those are, where I'm going to say, hey, this square park covers 9 square feet. Well, guess what, everybody? Square units, square feet, square inches, square yards, square anything. That is indicative of an area, because the only way that you can get an area is by multiplying 2 dimensions together. And when you multiply those units, you get square units. So before I continue, I know I'm not going to have everybody in the room with me on this one, but how many folks here feel like they understand simply how we got the square feet right there? Again, I don't emphasize things. I don't repeat myself unless it is very important. So even if you don't have it now, you're good. We're going to continue emphasizing this as we go on. I promise. All right, perfect. So that's just a quick example of area. Now let me go through a quick example of perimeter and why it's going to be different, both in how we calculate and in how it's stated in terms of the units. I got you. So right over here, everybody, let's go ahead and do this again. Same example, same example. Everybody, the perimeter is going to be the distance around the shape. If you don't have that written down, take a second to write that down. The perimeter is the distance around, emphasize the word around, that shape. So when we take a look at a square, everybody, we have 4 sides. What do we know about all 4 of these sides, everybody? What do we know about all 4 of the sides? Correct. They are all equal. 4 equal sides. And so when we consider the idea of perimeter, let me write that right there and then write this next one over there. So when we consider the idea of perimeter, think about this, everybody. We have 1, 2, 3, 4 sides that are the same. I am not a fan of writing 3 plus 3 plus 3 plus 3. No. If we're adding the same thing 4 times, we can just multiply it by 4. 4 of the sides. This is just a shorthand way of saying side plus side plus side plus side. So this formula here, again, is just a condensed version of the same logic that we know. Add up all the sides, and there we are. And let's go ahead and check this out when we plug in our values. Everybody, we had a side length of 3. 4 times 3, everybody, is going to give me what? Yep, that's going to give me 12, nice and easy. Now, the 12 is not really what I'm concerned about because I'm fairly certain that the majority of us here, we could do 4 times 3. But it's about the meaning of these numbers, the meanings behind these discoveries, that's really going to spell success. And here's what I mean. Everybody, did we multiply feet by feet, or was it just a number times the feet? Which one was it here? Was it feet times feet or just a number times feet? Yeah, it was just a number times feet. This is not 4 feet, everybody. This 4 is just representing the 4 sides. We're just adding each side 4 times. So there's no other unit. It's just feet. So when we think about it, and I hope that this makes sense when I talk about this as just a distance, because again, the perimeter is the distance around. This is just going to be regular feet. Why is it not feet squared? Because again, we're just adding up all the sides to get perimeter, and that stays as a distance unit. The unit for area is always a square unit right over here. And the unit for volume is going to be cubic. So to the 3rd power because it's a 3-dimensional unit. So again, I'm going to repeat myself well and often on this because once we get to the word problems, I won't be asking you, hey, what does that number mean? I'm just going to say which one's the area, which one's the perimeter, and I want you to use the reasoning for that when you go. So with that said, I'm going to give you a couple more seconds here, just 5 seconds here to go ahead and take your final screenshots. And we're gonna move over to rectangles in 2, 1, and let's go ahead and move it forward here. So here are the formulas for rectangles, and I'm gonna go ahead and just draw a nice unassisted picture of a rectangle right there with our length here and our width right there. So my party people, go ahead, take a moment, take these notes down, and then we are going to just do a little bit of an exploration right after and then get straight to our examples. So here you go. All right, so let's get into it here. Let's just review rectangles before the first example coming up. So first things first, everybody. When we are talking about the perimeter, in the chat box, let me know, what does that make you think of? The space inside the shape or the distance around? So give me space inside or distance around. Which one comes to mind when you think about perimeter? Perfect. Yep. Distance around. Distance around all day. And area is going to be the space inside. Everybody, just a quick pop quiz. When it comes to area, no matter what unit you use, is there an exponent and what is it going to be for area, for the unit? Yeah, square to power of 2. And then when it comes to perimeter, what is the exponent on that? What's the power on that when it comes to perimeter? When it comes to perimeter, yeah, just going to be 1. We're not going to show a power. It's just going to be 1 because it's just a distance. Exactly. So let's go ahead and tackle this here real quick. So when it comes to area, we have length multiplied by width. Again, multiplying your dimensions together. So length times width. That's what's going to give us all of this area, all of this space inside. And again, area is always a square unit. And then when it comes to perimeter, well, everybody, if this over here is the length and this over here is the width, if we're trying to calculate the distance around, we want to make sure we have all the sides. We're missing the top one and the right one, so help me out. What am I going to write over here on the top? What do I write up here at the top? This is the same as what? Perfect. Yes, that's going to be the same as the length. Exactly. The top and the bottom, the opposite sides of a rectangle, they're going to be equivalent. They're going to be equal. They're congruent. So we're good. They're the same. Same thing over here on the left side. What am I going to fill in here? What am I going to write over here? Correct. I'm going to write the width. Width. I spell that wrong all the time. So with that said, we have the length being the same on the opposite sides, and we have the width being the same on the opposite sides as well. So when you think about it, everybody, let's say this right here is our starting point. That way we don't confuse, while we go all the way around. When we go all the way around to find that distance, everybody, how many times are we writing down the width from the point that we start and we go all the way around to the finish? How many times is the width added up? Twice. Okay. How many times is the length added up as well? Twice as well. If you start here, you see that you have width and width, so that's twice. And if you go around, you have a length and length twice. So because of that, everybody, it's almost like saying, hey, let's just go ahead and add together the length and the width. And you know what? Let's just go ahead and double it. And that's really what that is. That's what this formula right here is. We are going to take the length and the width, add it together, and double it. Because we're going to add together 2 instances of each. So hopefully this right here isn't intimidating anybody. Again, this is just a shorthanded way to just say, add up all the sides. But instead of writing length plus width, we can shorthand it. And we can just say, hey, we have 2 of these lengths, 2 of these widths, and let's just go ahead and add them together. So with that said, does that make sense for anybody? Does that help anybody? Again, go from just memorizing to actually understanding what you're looking at, what you're dealing with when it comes to these geometry-based questions. Sweet, sounds good. Again, one of the most important things, and I'm gonna make sure I reiterate and repeat over and over and over again, is your ability to cut through the memorization and actually understand how to apply that memorization, how to apply that knowledge. So with that, let's go ahead and take it forward here to our first example problem. Everybody, first things first, we're going to be dealing with all word problems starting from here until the end of class. So for my folks who have been to my classes before, What's the first thing we always do, regardless of how long the problem is? It's the first thing we always do. Correct. We're always going to read the question. Some folks might use the acronym RTQ. That stands for read the question. And specifically, we're going to read the question sentence right there. So everybody, immediately it says, what is its area? So here's the cool thing about geometry-based questions that is really going to give you an advantage. Pay attention to this part right here. The advantage that you have when it comes to geometry-based questions is that there will always be a relationship or formula that you can take advantage of. Here's what I mean. Everybody, is there a formula for the term area? Is there a formula to calculate area? Yeah, absolutely there is. But here's one little thing that you have to think about. One tiny little detail. And it's this. Everybody, is it true that different shapes might have different formulae for area? Is that true? Absolutely true, right? Different shapes do indeed have different formulas. So when you think about when you're presented with a geometry specific question, and you know it's geometry because you're talking about shapes, perimeter, area, volume, surface area, the advantage that you have specifically is that there is a formula associated with it. And so if you know the formula and know how to use it, it's actually going to be a pretty easy time. Here's what I mean. We're looking at area. So the first thing I'm going to ask myself after that is, well, area of what? What shape? And I can clearly see right here that it says we're dealing with the area of a square. With that said, quickly from your notes, you got 10 seconds. What is the formula for the area of a square? Notice I said, hey, I'm looking for area. I see that the shape is a square. All I got to ask is, what's the area of a square? And boom, gracefully, y'all have flooded the chat box. And yes, correctly so, the area of a square is the side multiplied by the side. Another way to write it is side squared. Totally fine to write it that way too. I'll just stick to this with side times side. So now that we know what the formula is, I know that all I need is the side length, and I'm going to look at the information here, and it says, hey, it has a side length of 7 inches. Sweet. Sounds good. I'm done. I'm going to grab that 7 inches right there and multiply side times side. Everybody help me out. 7 times 7. That's going to give me 49, correct. But I'm looking for something more specific. I want us to really start doing this now before we got later. What are the units that we're going to use to describe this area? 49 what? 49 what? Be specific, my party people. No, it's not going to be square feet. What units are we using? Yeah, inches. So inches times inches, that's going to end up being square inches. So you can write inches squared or square inches. Either way works, but that is the proper way. So with that said, I know this one was straightforward, but are we good to move forward to example number 2? Sweet, sounds good. Let's go ahead and move it right along. Let's keep a pretty good pace here. So up next, again, first step, read the question sentence. What is its perimeter? Same as before, everybody. Once we have identified that what we're looking for is something related to a specifically geometric term, like perimeter, first thing I'm going to ask is, what shape? What shape? It's possible there might be a formula or not, but I know how I'm going to get it regardless. Add up all the sides, right? Add up all the sides. It just helps to know what shape we're dealing with. Yeah, and that's going to be the perimeter of a square right over here, just like we just did. And we're going to have perimeter of a square equals the 4 sides added together. And that's the same as saying 4 times the side. So in this problem here, I know it's no secret. It's the only other information that's not highlighted. We see this and we say, hey, it has a side length of 5 inches. So we're good. We'll move forward to calculate that perimeter to do 4 times the 5 inches. But what's that final answer going to be, everybody? 20 what? 20 what? 20 square inches? Yeah? Nah, just inches. Good stuff, everybody. Good stuff. That is going to be 20 inches. Not square inches, again, everybody, because the perimeter is the distance around the shape. The key word there is distance. Remember, distance is flat distance. Inches, miles, feet, yards, kilometers, whatever it is, it's a singular unit. Area is 2-dimensional, so it's a square unit. Volume is 3-dimensional, so it's a cubed unit. Watch, this is going to come right back to bite a lot of us in the butt, so keep paying attention here. But let's move forward to our first example where, hey, it's not so peachy. Take a look. Let's read the question sentence. It says, what is the length of one side? Okay, everybody. Did the question sentence specifically, again, what I highlighted here in red, is the question sentence specifically asking you for area or perimeter? Or is it asking for something else? What is it asking you for? Right, it's asking us for the length of one of the sides. We're asking not for the area, not for the perimeter. We're asking for one of the sides. Now, how is that going to affect our operation here? How's that going to affect how we're going to handle this? Well, pay attention. Remember, everything you do in the beginning, you have to just take it step by step and lay out what you have. I am looking for the length of one side, so I'll write that down nice and easy. So the side equals blank. Okay, sounds good. Now up next it says the perimeter of a square is 32 inches. So I know I'm dealing with a square, and I know the perimeter of said square is going to be 32 inches. So I'm going to just repeat that we are dealing with a square one more time right over here. Now this is where we want to get into asking ourselves questions, because I know a lot of us are excited, watching this as a recording or even here live. I see a lot of us saying, yo, divide, divide, divide. But we really want to get into the reason why we're about to divide. I got you. So everybody, quick question. We are looking for the side. We know we're dealing with a square, and we know that the perimeter of the square is 32 inches. Yes or no? Is there a formula for a square that relates the perimeter to the side? Is there a formula that relates the perimeter and the side of a square? Yes, there is. Absolutely. Go ahead now in the chat box. Give me that formula. The full formula with the equal sign and both sides. Give me it all. Perfect, Floor. You were the first one there. Perimeter equals 4 times the side. I'm going to write this down here in green. The perimeter of a square equals 4 times the side. Now, although this is a very straightforward problem with some very straightforward numbers, I totally agree with you there. What's more important that we look into here are the reasons why we made the choices we made. And it comes off of the question that I said before, and I'm going to say it again. What is it that connects what I have with what I'm looking for? You know it's a square, you have perimeter, and you're looking for the side. We're dealing with a square. Here's the perimeter, here's the side. So we know that this formula is connecting what we want with what we have. We know this is a solid connection. Now, where a lot of people mess up is where they plug the numbers in. How many of us here sometimes would accidentally plug in the 32 for the side? Because you see the formula, you see the first number, and you just throw it right in. And who here feels like they're prone to making that mistake? Cool, thank you for being honest. It's happened to me plenty. It's happened to me plenty as well. And remember, we can learn from those mistakes by first introducing and reinforcing the reasons why. Always, always, always. So with that said, here's how I know where the 32 goes. Everybody, when we look at the 32 right over here, the 32 inches, what comes right before it? What word right before it? Which of these words should we absolutely highlight? Yeah, perimeter, exactly, Antoinette. We are looking at the perimeter of this square being 32 inches. So with that said, everybody, which of these words am I going to replace with the 32? Again, the perimeter is 32. So which of these am I replacing with 32? And there you go. Again, it doesn't have to be super complicated, right? It doesn't have to be super complicated. This here is going to be our perimeter. So with that, I'll plug in that 32. And this is how we are going to discover what math we're actually supposed to do. Everybody, is the side by itself, or is there something in the way? Yeah, that 4 is in the way. Absolutely. So this is where we, take a step back. For some of us, it might be PTSD, but this is where we're going to take a step back to solving equations. So when we take a look, we're trying to get the side here by itself, but there is a multiplier of 4. We're multiplying by 4, and that's in the way. Well, the cool thing is, everybody, working backwards is all about doing the opposite operations. So what's the opposite of multiplying by 4, my friends? Yeah, that's going to be dividing. That's division. And so what we're going to do here is we're going to divide both sides by that 4 to get rid of it from the right side, because you're going to see it's going to cancel. Doing the same thing, or the opposite thing, multiplying by 4, then dividing 4, that's going to cancel out. So that's going to leave our side by itself. And help me out, everybody. What's 32 divided by 4? Yeah, it's going to be 8. There we go. And because it's just the side that we found, is that going to be 8 inches, or is that going to be 8 square inches? Which one is it? That is correct, 8 inches. Not square inches, just regular inches. And there we are. The side length of this square is 8 inches. So who feels like we're good to continue on, to continue upping the ante? One example at a time here. Hey, right on, everybody. So again, remember, perimeter, that's just flat units. Area, square units. Keep that in mind. So let's move forward here in 3, 2, and 1. Here we go. Everybody quickly, give me one word to describe what we are looking for. Go. 5, 4, 3, 2. Yes, that is correct. We are looking for the perimeter. So I want to start training you on this now, to immediately look at the question sentence. I do not care what any of this here says. I don't care. It doesn't matter what it says until you know the purpose of you spending your time in this space. It says, what is its perimeter? Everybody, what did we say? The next thing I'm going to ask is, after we see a hyper-specific geometry term, what's the next question? I'm looking for the perimeter. But the perimeter of what shape? Exactly. Bukola, great response there, very quick. Again, the moment I ask myself, or I figure out that I'm trying to find a hyper-specific geometry term like perimeter, I'm going to say, what shape? What shape? So that way, I can go through my little brain here and figure out what formula is going to work best. So here, perimeter, and here it says rectangle. So we want to figure out the perimeter of a rectangle. And my friends, quick question, what's the formula for that? Yeah, double the length plus double the width. That makes the 4 sides, exactly. So I'm gonna write this down over here. We have 2 times the length plus 2 times our width. Now, before we even read the information, everybody, because we're trying to find the perimeter of the rectangle, what is the 1 or 2 things that we need to be able to plug in and solve for the answer? What are the 2 things that we need here? We need to know we need to know the length and we need to know the width. If we have the length and the width, then we're good to go. And if we don't have them, then we're gonna have to do a little bit more work. But let's hope that the problem gives us what we need, but also be confident in ourselves that we know what we'll need to do to figure it out. Thankfully, this is again still an example. And it says that the length is 8 inches and the width is 5 inches. So really all we have to do at this point is just plug these values in and just continue on with our day. Length of 8 inches, width of 5 inches. Let's plug all that in. My perimeter equals 2 times my length, which is 8, plus 2 times my width, which is 5. Boom, there we go. I've plugged in what I need. And now we can just calculate. So let's go ahead and have a little bit of respect for the order of operations, one by one here. So first things up, we have 2 multiplied by 8, and that's going to give us 16. So perimeter equals 16. And then we have a 2 times 5 over here, and that's going to be 10. And this is the hardest part of my day personally. So 16 plus 10, that's going to be 26. Perfect. But help me out, everybody. You know we haven't been lazy yet. 26 what? Square inches, regular inches, something entirely different? Yeah, it's just going to be inches. Now, give me a reason in the chat box, everybody. You know I'm going to test you. Give me a reason other than that it's perimeter. Why is perimeter flat units? So in this case, just inches. Why is perimeter just inches in this case? I'm looking for the D word that I described perimeter as. Jasmine, first one there, perfect. Yes, that is a distance. Perimeter is the distance around the shape, and distance is just a regular unit. Great job so far, everybody. Seriously, you're doing a good job. So, again, this was a perimeter problem working forward. I can absolutely empathize and understand if some of us are feeling like, "Ooh, I know we got that right, but this seems a little complicated. I'm a little afraid for when we have to work backwards." Don't worry, I'm going to have your back every step of the way, but just know that it's not about only working forward. We are going to get to an example at some point here, the next couple of examples of working backwards. But let's go ahead and take a look here at this next one. Oh, look at that. We're here. So let's go ahead and take care of business. Everybody, quick question. Read the question first. The question sentence. What is it that we are looking for? Yeah, notice that even though we see the trigger word perimeter here, we see here the question sentence. What is the width? Right there, you can't miss it. So always start with the question sentence, everybody. The who, the what, when, where, how many, which of the following. Those are all question action words that we really want to pay attention to because that's going to tell you, hey, this is your goal. So with that, cool, we're looking for the width. So I'll just write that right over here. I'm looking for the width, blank. Now, quick question, everybody. This is where we start gathering our information. What shape are we dealing with here? Because we got an inkling that we're dealing with geometry because we're looking for a width. So what shape are we dealing with? Yeah, we're dealing with a rectangle. Sounds good, right there. So I'm happy to say that I can draw a rectangle without any help. There we go, booyah, nice. And then up next, what do we know about this rectangle, everybody? Tell me, hit me in the chat box. What do we know about this rectangle? What is given to us here? Okay, I saw that we're saying 24 inches. What does that represent? What does the 24 inches represent? Yeah, that's the perimeter, yes. So right over here, let me highlight this in a different color. Let's use purple. So it says the perimeter of the rectangle is 24 inches. So I can absolutely write that down right over here. Perimeter equals 24 inches. Perfect. Next up, in the next sentence, in the question sentence, we see that it says, if the length is 8 inches, what is the width? So everybody clearly, or do you agree that clearly this problem says that the length is 8 inches? Do you agree with that statement? Cool, sounds good. Then write your information. My length equals 8 inches. So at this point, I think we all know that this isn't working forward, it's working backwards. But I think the better question is, how do we handle that? How do we manage setting up and solving this problem working backwards, especially when the formula isn't the easiest thing to remember? Hey, no worries. First things first, everybody. First things first, what is the formula that connects the perimeter of a rectangle, the length of a rectangle, and the width of a rectangle? What is the formula that connects all three of those ideas that we're given? Yeah, give me the full thing though. Give me the full formula with the equal sign, with both sides. I don't want you to just say 2L plus 2W. I want you to say blank equals blank. Give me both of those. There you go. Perimeter equals, let's write this here. The perimeter equals 2 times the length plus 2 times the width. Right there. Remember, everybody, it starts with knowing your formula, and now we're moving into how we're going to use this formula. Everybody, no matter what we are plugging in, which value are we not going to plug anything in for? Let's see who knows this. Which of these are we not plugging anything in for? The perimeter, the length, or the width? There we go. You guys are sharp. Yes, we are not going to plug anything in for the width. Remember, everybody, we are looking for the width. So this right here is going to stay as is. I know what my perimeter is. My perimeter is 24 inches. So I'm going to replace the perimeter with 24. I also know my length, and I'm going to replace that length with the 8 inches that I have. So here it's going to be 2 times 8 plus everything else that we still have, 2 times the width. Before I continue, before I get into working backwards and solving this equation. Who here is starting to pick up on the most important step being knowing not just what values to plug in, but where to plug in those values. Knowing if you have the perimeter or the sides. Knowing if you have the area or are looking for the area. You have to be able to take a moment and analyze before you calculate. And it's going to take time to really get this down in real time, but I want to continue expressing this and keep opening your eyes. I got y'all. So with that, we've plugged in everything. Again, let me just remind you about how we got here. The perimeter, that's 24 inches right over here. So the perimeter we replaced with 24. The length is 8 inches. So the length I replaced with 8. Now that I've gotten that part done with replacing what I've had, now let's clean up this equation. Let's just clean that up, get rid of that, get rid of the 2, so we can get that width all by itself. Help me out, everybody. 2 times 8, what is that? Hit me with it. That's gonna be 16, right on. 24 equals 16 plus the 2 times the width. Nice and easy. And then from there, everybody, how do we do this? The 16 is just sitting there, right? 16 is just sitting there. It's considered a plus 16. It's considered a positive 16. So how do we get rid of a positive 16 from the right side? Yeah, we're going to subtract, exactly. Opposite operations. A number that's just sitting there is considered to be added there. This 16 is being added there. So what we can do is we can subtract this 16 and, we have to follow the law. We don't want to get arrested by the math police. Oh, no. So we have to go ahead and do it to both sides. Nice and easy. Once we do that, let's go ahead. Booyah cancels out on the right side. Let me get that back in frame for you. Cancels out on the right side. And so everybody, 24 minus 16, like y'all are excited for in the chat box, that will be 8. So we have 8 equals, don't forget that there was a 2 still right there. 2 times the width. So remember, guys, solving equations, all about working backwards. The answer is not 8. We're not done yet. We have to get rid of this 2. And the way that we're going to get rid of the 2 is by dividing both sides by that 2. Simply because, remember that we do the opposite operations. That's multiplication. So the opposite is division. So once we divide, that cancels out on the right. 8 divided by 2, that's going to leave us with 4 what, everybody? 4 what is going to be our width? Correct. In this problem, it's going to be 4 inches. That's going to be our width. And we're all good. So all in all, so far, everybody, we've done examples where we've worked forward, examples where we've worked backwards, but notice how we're still using the same formulas. It is up to us to be able to see, hey, not only do I know what formula we're using, but I also know which pieces I have and which pieces I'm looking for. So one more time, who feels like they're growing a little more confident now with understanding this method? Sweet. And again, it's going to be bit by bit, again, problem by problem. We'll continue doing this. And I want you to always try to communicate with yourself about what's going on. Like, do I notice that we're talking about area or perimeter? Do I notice that this is supposed to go there? This is plugged in there? And then if there's something that you're not quite strong with, totally fine, everybody. Because solving equations, you can work on that. Calculating with mental math, you can work on that. I really want us to focus more so on identifying what formulas we need and what's plugged in where. So with that, everybody, let's move forward here to the next example. Let's keep up the great work. So, first things first, everybody, what are we looking for? Yeah, that's right. We are looking for area. That is correct. We are looking for area. And then what did I ask, everybody? What did I ask you to ask as soon as you see that you're looking for a hyper-specific geometry word? I want to find the area, but then my next question is area of what? What's that S word? Exactly, what shape? Again, area is a very specific geometry word. So, okay, area, but of what shape? And then the first sentence here says rectangle. No other shapes mentioned, so I can be very confident that we are trying to find the area of a rectangle. So I'm gonna go ahead and just do this. Area of a rectangle equals what, everybody? What did you have written down in your notes? Length times width. That is correct. Area equals length times width. There we are. Perfect. So with that said, let's go ahead and see what values we have, plug it in, and we're all good. Here we go. I see here that we have a length of 9 inches, a width of 4 inches. So all we have to do here, hey, just plug it in. You're good. So length was 9. So I'm going to plug in a 9 right there. The width is 4. Plug in the 4 right there. That's easy. That's doable. So everybody, length times width, 9 times 4, that'll give us what? 36. I don't think that's enough information. Not 36 inches either. Which one is it going to be? Yeah, 36 square inches. You can say inches squared. That works just as well. But I really want to get us honed in on those units. Again, area is a square unit. You are defining space, not a straight line distance, but a space, how much space you have. So there we are, my party people. There's another one knocked out of the park. And so with that said, everybody, we have one more here before I'm going to start putting up some examples for you to try under a timer. And if you are watching this as a recording at home, then you'll have your own timer to set up. But if you're here live, I got you. So last one here before we get into that. Quick, what are we looking for? Go, go, go. 5 seconds. 4, 3, 2, 1. Start typing it in. And I'll give you 1 more second to finish and typing enter. Yes, we are looking for the width. I know I'm definitely giving some folks test anxiety because I'm putting you under a timer, even for the simplest questions. I totally understand how that heart rate might start racing, but I really want to get you used to that pressure, little bit by little bit. So here we go. We have the width is what we're looking for. Well, what information do we know? Well, I know I'm looking for width, so I'll just write that down right there. Well, let's see what information we're given. So the first thing I'm going to read here is the area of a rectangle is 36 square inches. So right there, I just discovered a hyper-specific geometry word area, and I also discovered the shape that we're dealing with. So look at that. That's 2 great things already. We're dealing with a rectangle. The area of said rectangle is 36 square inches. And we also see that the length is 9 inches. So L equals 9 inches. Now, if you are recognizing these numbers, there is a reason for that. So with that said, everybody, let's go ahead and understand that, hey, to solve this problem, we need to know the connection between the width, the length, and the area of a rectangle. Everybody, what's that formula or relationship going to be? Give me blank equals blank. Don't take shortcuts. Formula, perfect. It's going to be area equals length times width. Yes, there we go. So area equals length times width. We know this is the correct one that we will use because, again, it's the relationship between a rectangle's width, length, and area. Width, length, and area for a rectangle. Boom. Now we can be confident that we have the right formula. Now let's make sure we plug everything in to the right place. So the area right over here, that's 36 inches. So let's make sure we plug things into the right place. And then the length, we see it right here, 9 inches. So I'll make sure that the length right over here is replaced with 9 inches. And then we have the width right there. And here we go. What operation are we going to perform to both sides to get the width by itself? Perfect. Yeah, we're going to divide. We're going to divide. So with that, everybody, we're going to divide both sides here by that 9. Nice and easy. And so with that, booyah cancels out on the right side. 36 divided by 9. What do we get? Yeah, it's going to be 4 inches. And there we go. Again, remember everybody, lengths and widths and side measurements, they're always going to be just regular units. Perimeter? Yep, regular units. Area, square units. Always, always, always. So our width in this question, in this problem here, 4 inches. And so there we go, everybody. We've done at least one example of, or mostly all of the examples for working forward and working backwards. Do we feel like we're perhaps ready to start some problems on our own? Right on, sounds good. Some of us are saying, one more, don't worry, I got you. We'll go ahead and go one problem at a time, and we'll go over it after you have a chance to try it on your own. Don't worry, I got your back. All right, so let's take care of this first problem here. We have A rectangle has a length of 4. Remember, everybody, I'm going to stop myself right there. Do not read the question start to finish. Instead, go ahead and begin with the question sentence. What is its perimeter? All right, everybody. So when we take a look at that here, what is its perimeter? Well, everybody, we know it's a hyperspecific geometry word. So what are we going to ask right after that? What is its perimeter? Perimeter of what? Perimeter of what shape, right? So now that we ask ourselves that question, perimeter of what shape is it that we're dealing with? Perfect. It's a rectangle. Absolutely. So we see it right there. So what we're looking for is the perimeter of a rectangle. Can somebody give me the formula for the perimeter of a rectangle? Oh, you guys are quick today. Let's go. So that's going to be 2 times the length plus 2 times the width. There we go. So with that going on, everybody, all we need to know to solve this question properly, to find the perimeter, is we need to know what the length is, and we need to know what the width is. Thankfully, in this problem, we're given that. So we're good. We see that we have a length of 14 centimeters, width of 6 centimeters. So we'll go ahead and plug those in, and then just calculate. 2 times that length of 14 centimeters plus 2 times that length of 6 meters, or that width of 6 centimeters. So we have all of that going on, and let's finish things up the right way. So here we go. We have 2 times 14, and that's going to end up being 28. We also have 2 times 6 right over here, and that's going to end up being 12. So now that we have 28 plus 12, we'll add those together. My party people, help me out. I'll write this down on the side. 28 plus 12, what's that going to be? 8 plus 2, that's going to be 10. Carry the 1. 2 plus 1 is 3. Carry that other 1 is 4. So we have ourselves 40 centimeters squared. Is that correct, everybody? It's almost correct. It is almost correct. Remember, perimeter is a distance. It's not supposed to be squared. 40 centimeters squared? Nope. It's just 40 centimeters. That's our answer, everybody. The perimeter that we're looking for is 40 centimeters, and that's going to be identified as answer choice B. Hey, I'm not trying to confuse you. I'm trying to, how do I say this? Some of y'all might call it torture, but I'm calling it mentoring. I'm trying to mentor you now, so that way, when I'm not there to hold your hand, that you at least have my voice echoing every single moment of the day. I'm kidding. That at least you have my voice in there reminding you about what to look out for. So with that, I got y'all. We're going to keep doing these questions, and you're going to see exactly what I mean in about 3, 4, 5 questions. And then you'll be like, oh, that's why he was repeating that so many times. Watch. I got you. So with that, let's go ahead and move it over to the next question. I got your back, everybody. Just give it your best, just like we have been doing. Keep it up, everybody. And remember, I'm going to give you the 2 minutes again, and then we'll review it after that point. Let's review this next question here. So the question is asking for the perimeter of this park. What is the perimeter of the park? All right, everybody, I think we all know that we are specifically talking about perimeter. So let's just go ahead and highlight that a couple more times. But we always want to ask everybody, perimeter of what shape? Yeah, that's going to be a square park. That is correct. So with that said, everybody, we are looking for perimeter, and we are looking for the perimeter specifically of a square. So the perimeter of a square, everybody, that's going to be what? What do you have in your notes? What do you have? Yeah, that's going to be 4 times the side, because remember, everybody, a square has 4 equal sides. All 4 of these sides are the same. So if you have one of the sides, sweet, you're good. You can go ahead and multiply that by 4 and you'd be done. Now, let me go ahead and do that for us here and explain why a lot of us may have gotten a different answer than what the correct answer was. I got you. So we have 4 times 15 meters. And so we'll go ahead and do 15 times 4. And that's going to be 5 times 4, that's 20. And then 1 times 4 is 4, plus the 2. That's going to give us 6. So this is going to be 60 meters, not square meters, just meters, because this is perimeter. Now, quick thing. I'm going to highlight the right answer. That's going to be A, 60. But I'm going to highlight the incorrect answer that a lot of us picked, and that's going to be 225. Now, why did we get 225? Well, I think the easiest way to really explain this is just we might have gotten this confused with the area. We might have gotten this confused with trying to find area. In the confusion and the rush and the pressure of being timed, it's okay if some of us said, okay, cool. Oh, to find this, all I remember right now is side squared, side times side, 15 squared, 15 times 15. And before you can even double check, before you can even think about if what you're doing is for the right reason, you calculate and you get 225. And it just so happens that you see 225 and you said, bet, I am locked in. Who here did that? Who here did that? They just did the first thing that came to their mind, and then they saw the answer actually there for themselves, and they thought that that was going to be it. So, one thing that I will say is the number of people that selected C versus the number of people admitting that they selected C, they're two different numbers, two different amounts, but I'll go ahead and keep that to myself. Oh, wait, this is being recorded. Okay. So, with that, let's go ahead here and just remind ourselves, everybody, look, it is not about the numbers. It's about what the numbers mean. So with that, just read through the question sentence first. What is the perimeter? And you really want to take a moment to think about, hey, if this is a hyper-specific geometry word, is there a formula behind it? If so, what's that formula? And then once we have that, let's collect the information. Remember that we want to go through that essential fundamental strategy instead of just rushing to calculate. So with that said, take your screenshot if you need to before we get into this next one. Take that screenshot if you need to. Let me erase that 225 for you. So take your screenshot and we are going to move forward to our next question here momentarily. All right, so we just had the chance to try out the problem that we see here on the screen. So let's just go ahead and let's talk about it. So this one's a little different than the ones that we tried already. And I saw from the responses that, yeah, not everybody's in agreement. Not everybody agrees on what the answer is. So with that said, everybody, we are doing a class, as you already know, on area and perimeter. But what's different about this specific problem, everybody? Versus the other questions that we've tried, what's different about this problem? Yeah, sure, we're dealing with yards, but no worries. We've dealt with centimeters and inches. I don't think that's terrible, right? We want to know the length. Well, we've tried to find the length already. We've done a problem like that. Come on, what's the difference in this one? Yeah, we need a little more information, right? Because let me ask you this, everybody. Even though we're doing a class on area and perimeter, are either of those words, area or perimeter, explicitly written on the screen? Is area or perimeter explicitly stated on the screen? No, it's not. So that's what makes this problem different, and that's what makes this a much closer example to a test level example. So let me go through it with you. And once we have the aha light bulb moment, I'm also going to be like, I told you so. So here we go. First things first, as always, everybody, let's read the question sentence. So it says, based on the coverage provided, what is the length in yards of one edge of the backyard? Okay, everybody. So what's the one word that we should highlight, from this question sentence? What's the one word that we really want to emphasize? Yeah, that's going to be the length. We want the length right there. So we want to know the length, and they say in yards. So we'll just say length equals blank yards. Okay. That's step number one. Again, just process the question sentence. Now from there, let's read through and see what information we have. And it says, a square backyard is fully paved with decorative tiles and covering. But first things first, everybody, we can confirm that we are dealing with a square. Yes or no? Yeah, absolutely. So let's go ahead and write that down. Dealing with a square. Okay, great. And then it says again, a square backyard is fully paved with decorative tiles covering a total of 64 yards squared. Square yards. Now, let me go ahead and just, really ask myself, because, my voice is giving out already, and it's because I said a certain thing over and over and over again. Everybody, when a unit is given to you as a square unit, what is that indicative of? What is that representing? Yeah, that's representing an area. So let me go ahead and just highlight this for us here. Let me go ahead and use blue. So it says, so the square backyard is fully paved with decorative tiles, starting right here, covering a total of 64 square yards. Square yards, covering. We're talking about space here, aren't we, everybody? Can we confirm that? Did I not say earlier that when the units are squared, that is area? So remember, everybody, those little things are very important, those little details. Notice I didn't give you area or perimeter specifically. It was up to you to discern that, to infer that, to break it out, to interpret it from the context. So now that we know that, now that we know that we're given the area as 64 square yards, now we can do work with this. Because, everybody, what is the formula that connects the length of a square and its area? What is the formula that connects those two ideas? Yeah, the area equals side times side. You can also say side squared. Both of those work perfectly fine. So that's what we have here. Let's write it down. The area formula for a square specifically is going to be side times side. Absolutely. And so now that we have this, my friends, well, which of these are we going to replace with that 64 that we found? The area or the side? Which one are we replacing? Correct. That's going to be the area. So that area being 64 square yards, I'm just going to replace that area and see where the problem takes me. So that's going to be 64 square yards equals side times side. So this is the question you want to ask yourself, everybody. What number multiplied by itself gives you 64? Is it 4 times 4? Nah, that's 16. Is it 8 times 8? Absolutely, it's going to be 8 times 8. So our side length is going to be 8 yards. And there we are. Booyah, right there. The correct answer here is answer choice D. So before we continue, how do we feel? Who here feels like, because again, look, the only difference between this problem and the previous problem was a couple of more words, and I just didn't explicitly say area or perimeter. That's all it was. That's all it was. I just didn't explicitly say area or perimeter. And notice how the entire chat here got discombobulated, really. No one agreed on the same answer. So this is what it's all about. This is really the important part. It's not about the numbers. It's about figuring out what the numbers mean. Everybody, before we continue, is that an agreeable statement? It's not about what the numbers are. It's about what the numbers mean. And let's take a look at this next one. So the first thing, again, as always, that we want to do is, well, read the question sentence. So right here, if one of the edges measures 12 feet, that's just conditional information. They're giving you information here. You're good. But it says here, what is the length in feet of the adjacent edge? Okay, what is the length in feet of the adjacent edge? So one thing that I have here is that, yeah, sure, we're looking for length, but I'm already curious about what the side might be, right? Because if we're asking for the length and we see that, one of the other edges measures 12 feet, I might just go ahead and call that the width. So I'm going to go ahead and just say, hey, other edge, I have a length, but I'm going to mark the other one as width, 12 feet. Let's just go ahead and see what we have. Let's see what information we're dealing with. So it says a rectangular playground. Okay, cool. So I see that we have a rectangle. So let's write that down. Rectangle, nice and easy. So a rectangular playground is being outlined with a 50-foot long string of lights that run along its entire boundary. That doesn't say perimeter. That doesn't say area. How can we figure out which one this might possibly be? How can we possibly figure that out? Well, really, it's just going to be about reading the context. Let's draw a rectangle, and let me show you what I mean. Everybody, if we have this rectangle that we're discussing, and we're trying to outline this rectangular playground with a 50-foot long string of lights that run along the entire boundary, what does that sound like we're discussing, everybody? If we're outlining it with 50 feet of stringed lights, exactly. That's perimeter. That is the distance around the shape. So remember, everybody, it's not just about memorizing, it's about using the context, understanding the context. And right here, my friends, that's going to be the perimeter that we are going to write down. We know that the perimeter is 50 feet. And one more question, everybody. Even if you might have thought that this was area, what is the one thing that you can point to say, for sure, this is not area? What's the one thing you can point to? Yeah, right here, the unit. Feet. The unit feet. Even if these numbers or these words don't make sense to you, outlined, entire boundary, you can look at the word feet. That's just a distance. That's not area. That's not a square unit. Area would be squared, exactly. So we have to make sure that, again, we can give reasons for why we make decisions. That's going to help you out through and through. So with that, my friends, here we go. Let's go ahead. Try to grab the rectangle there. Let's go ahead and grab the rectangle, make it a little smaller, place it over there, and let's fill in what we have, and let's just solve. Here we go. So the perimeter that we have for a rectangle is 2 times the length plus 2 times the width. Fill in the blanks with me, everybody. What is the perimeter of this rectangle? We already wrote it down. That's right, it's going to be 50. Next, we're going to do 2 times, well, we're still looking for the length, so I'll just keep that as L. And then we have 2 times the width. Everybody, the width that we have written down is what? 12, exactly. So with that, I'm going to zoom in on this portion here. My friends, if while you tried to work on this by yourself, if you were able to understand that we were given the perimeter and the width was 12 and you remembered your formula, then you're good, everybody. You're good. We'll calculate together now. We're good to go. But I just want to really encourage anybody who feels like they didn't have enough time to calculate. I want to reassure you that you're doing the right thing. So booyah, the perimeter was 50. Double the length plus double the width. All we're doing is replacing what we have. Still looking for the length, so we'll just leave that as L. The W, the width, that's 12, and let's get going. Now it's time to solve. Here's how we do it. First, everybody, what's 2 times 12 going to give us? Correct, 24. So we have 2 times L plus 24. Now from here, what do we do next? Do we take care of the 2 next or the 24? Which one do we take care of? Yeah, it's going to be the 24. We want to get rid of that 24 that's just sitting right there. We see that it's plus 24. So we will do the opposite. The backwards operation will be subtracting 24 on both sides. And once we do that, we see that it cancels out on the right side. And so now we have 50 minus 24. We can borrow and do our thing, no problem. So 10 minus 4, that's going to be 6. 4 minus 2, that'll be 2. So 26 equals double the length. Well, some of us might get a little excited at this point. And if we saw that 26 was one of these answers, thankfully it wasn't. If 26 was available, I know some of us might have been tempted. But at this point now, we just need to finish things up. And we're going to go ahead and divide by 2. And that's it. Right on. So with that said, divide by 2 on both sides. Nice and easy. Cancels out on the right. 26 divided by 2 is 13. And we are all good. So with that, length equals 13. 13 feet to be exact. And we are all set. Answer choice is C. And there we are. So with that said, everybody, as always, got to ask you, how are we feeling about this? Do we feel like we are making progress, at least in the area of translating that English into math? All right, let's take a look at another interesting question. So as always, my friends, first thing we do is we're going to read the question sentence first. So again, fundamental strategies here. What is the measurement of the adjacent side? Okay, sounds good. So we want to know the length of some side, but nevertheless, I'll just write it right here. Side equals blank. It could be a length, could be a width. I don't know. Who knows? But we know that we're looking for the length of one of the sides. Now, up next, what shape do we see that we're dealing with? It's shown to us first in that first sentence. We are dealing with, in this case, a rectangle right over here. So in that rectangular classroom, one side measures 15 feet. And everybody, quick question, when it comes to rectangles, how many unique sides are there? A side for a square, it's just one unique side. They're all the same. But in a rectangle, yeah, we have two unique dimensions. One of them is a length, the other is a width. So seeing that we're dealing with a rectangle, I'm gonna edit this right over here and say, hey, instead of saying side, I'll just go ahead and say length, and then I'll just write a placeholder for the width or how wide it is. So right there, we see that one side measures 15 feet. Okay, sounds good. But really what's important is gonna be this next part. And I'm gonna highlight this in blue. So it says the floor is entirely covered with carpet that spans 195 square feet. Everybody, question, what does that 195 represent and why? More importantly, give me the reason why. So whether you believe it's perimeter or area, give me the reason why. I see a lot of folks saying area coming in. So that reason with it, what's it gonna be? Yeah, some of us might be, really pointing at the word covered or entirely covered. That's really good too. But the solid, concrete, 100% evidence that we have right here is square feet. That right there, everyone, that is the solid evidence. If you were trying to say perimeter, perimeter is just a singular unit. It would just be feet. When we're dealing with area, that's two-dimensional. So you need a square unit. So that's how we know for a fact that this is area as 195 square feet. So now that we have that going on, whether you knew it or didn't before, again, just trying to reinforce the reasons why, but let's go ahead and lay everything out, calculate, and we're good. So here we go, my party people. We have area of a rectangle equals what? Pop quiz, give it to me. The area of a rectangle is going to be, it's going to be 195, and the formula correct is length times width. So because we know that the area is 195, we want to replace the area with 195. Again, nothing too complicated. Just replace things where they go. We also know that our width here is 15 feet. So we'll just go ahead and write L times 15. So now that we're here, let's really turn up the pressure and ask ourselves, how are we going to get the length by itself? How are we going to get the L here by itself? What do we have to do to both sides? Yeah, we're going to have to divide. Exactly. We're going to have to divide, and we have to divide consistently across both sides. So I'll divide both sides here by 15. Nice and easy. And so it cancels out on the right. And you might be looking at 195 divided by 15 like, what? Coach, I don't like that at all. And there's two ways that we can really go about this. One is by trying the long division way, 15 into 195. That is one way. Another way is, 15. If you're dividing by 15, 15 is 3 times 5. So if you wanted to, you could first divide this by 5. Then whatever you get is the answer, then divide it by 3. Again, divide by 5, then divide by 3 if you wanted to. With long division, I think it'll be a similar difficulty, and we can show you that right here. 15 goes into 19. That'll be 1 time. We subtract that 1 time, so subtract that 15, and we get 4 left over. If we drop the 5, we have a 5 at the end, so 45. Who here knows how many times 15 goes into 45? Yeah, that's going to be 3 times. And so there we are. That's a perfect, clean 45 with no remainder. So we get 13 as that leftover. So again, L, the length is what we're looking for. So that's going to be the length equals 13 feet. Again, it's just a length, so it's just going to be feet. If we were looking for the area, that would be square feet. If we were looking for perimeter, that would just be regular feet. So with that, everybody, there we go. Our correct answer for this problem here is D, 13 feet. And there we are. Again, this was just part 1, everybody. Part 2 is coming with us tomorrow. And in part 2, we're going to be doing problems where this difficulty that you see right here is the bare minimum. Tomorrow, I'm really going to challenge you to not just memorize your formulas, but use your formulas as part of a bigger problem. And with that said, that's an excellent job today, everybody. How do you feel?